Let's continue substitution rule. So in previous sessions, we discussed about substitution rule for natural log functions. In this session, I'm trying to apply that substitution rule with exponential functions. So let's start with this one. So once again, so the idea should be creating that derivative, right? So for example, okay, let's start with this one. Right? Oh, so what's the inner function? It's slightly difficult to identify, right? So, but I'm going to differentiate this denominator for no reason. Let's see. Right? Because that denominator, we can use that denominator, exponential x plus 1. We can use that part as our substitution if the derivative of that part, if you can observe that inside this integral. For example, the derivative of exponential x plus 1 is exponential x. There is a term next to this function, like exponential x. Then we can complete this problem. Why? Because then this exponential x, I can express that function as the derivative of exponential x plus 1. So that's the idea. Like this. So that's the desired form. Hence, we can use u equals exponential x plus 1. But we can't do that because I don't see exponential x term inside this integral. So therefore, let's try to build something like that. So for that, I'm trying to create something. So, so we need exponential term for the numerator. Right? So to create that, I can multiply both numerator and denominator by exponential minus 6. Like this. Exponential minus x over exponential minus 6, that's 1. Right? So I'm going to do that. Because that's the process of creating an exponential x term, the numerator. And also we can simplify the denominator. That's why I picked exponential minus 6, because if you pick exponential x, if you multiply by exponential x over exponential x, basically you are changing that. The simplification of the denominator slightly different. So then you will get exponential 2x plus exponential x for the denominator. That's not good. Right? That's why we use this. So if we expand this, exponential x into exponential minus 6 plus exponential minus 6. Here, I'm happy to keep this term because that could be the derivative of the denominator. Let's see. Now, we can simplify this part very easily. That is, we can add powers x plus minus x, that's 0. So exponential 0, that is 1. So 1 plus exponential minus 6 times exponential minus x dx. Then, as you can see, we can use 1 plus exponential minus x as our substitution, because the derivative of that part equals to exponential minus x times minus 1. I just applied the chain rule. So minus exponential minus x, we can easily create minus sign here. We can multiply that term by minus 1 times minus 1, that is plus 1. Right? So then we can easily complete that problem. So I'm going to write minus 1 here, because that's just plus 1. Then we can take this minus 1 out. Then we have minus 1 exponential minus x dx. That is basically the derivative of 1 plus exponential minus x. Therefore, we can express the function inside the integral like this. So that's the desired form. Hence, we can use that substitution u equals 1 plus exponential minus x. Afterwards, it's very easy. I think you will get an answer like this. Natural log of 1 plus exponential minus x plus c. That's not difficult after that. It's about creating that form. Similarly, I believe you can try this problem also. Maybe for this one, multiply both numerator and denominator by exponential x. Yeah. Then you will get something like this. So that's it, because this is the derivative of this part. Then the answer is going to be natural log of 1 plus exponential x plus c. Very easy. So same idea, not the same idea, but again, if we had a function like this, we can easily integrate this function, right? But why can't we integrate this one? I think because of the denominator. So it's always worth differentiating that denominator whenever you have a doubt, right? So let's differentiate the denominator. Exponential x plus exponential minus x times minus 1. Basically, that's the numerator. Hence, quite easy. I would like to express like this integral. This part is basically the derivative of the denominator. I think that's it. That's it. So this is the substitution. U equal exponential x plus exponential minus x. Then du over dx equals to exponential x minus exponential minus x. We did that differentiation here, right? Therefore, du equals to dx. So basically, this part, that dx, that is du, that orange colored part. In the denominator, we have u. So basically 1 over u du or du over u, like that. That is 1 over u du natural log of u plus c. Natural log of exponential x plus exponential minus x plus c. So that's the idea. That's how we identify the correct substitution. So you can try this problem also. Again, focus on the inner function. I think this is the inner function. So differentiate that. Then the derivative of that 1 minus exponential x equals to minus exponential x. So minus 1 is not a problem. We can create that always. So we have that. Therefore, I think you can complete this. The substitution is basically like this. Minus exponential x dx. I'm going to put another minus sign here because I did create minus sign. So minus into minus plus. So basically, I did not change anything. Then that is 1 minus exponential x square root 1 minus exponential x here. Here, the key here is we are not worrying about the square root. We are not substituting. We are not using a substitution for the entire thing. We are focusing on the inner function, right? Because after using that substitution, u equals 1 minus exponential x, you will get square root of u here. So that's not a problem at all, right? And here du. Once again, the idea should be identifying the inner function. Then you can integrate this. And try this one too. Same idea, quite similar. This is the suitable substitution. Then you have the derivative of that function here. We can, of course, create constants. For example, in this case, minus 2 exponential minus 2x. So to create minus 2, you can multiply and divide this integral by minus 2. Then take that minus 2 out. Minus 2 in the denominator out. Then you will be able to complete this. And so we can generalize this result using a symbol like A. So try that. A is just a constant. A is a real number. Because that way, basically, like solving 100 problems. Because if we can use a symbol like this, it's like solving so many problems with numbers. So try to use those symbols whenever possible to create a pattern. To, yeah. That way, you'll be able to solve so many questions without solving so many questions. By identifying a pattern like this. Don't need to remember anything. That's not the aim. Aim should be identifying, recognizing these patterns, identifying inner functions. Because then, whenever you have a question, you will be able to understand, you will be able to identify the correct substitution. Yeah. Okay, thank you.